Okay, good morning everyone, or whatever time of day it is for you. Welcome to our first lecture. Some of our lectures will be done in my barn with animals wandering around. A couple baby geese just came in and I will shoo them out of here. So as you go through these lectures, feel free to push pause. You may have to go back every once in a while and relook at something. Let me know if you find any mistakes. Note the time that on the video, and send me an email, and I will go in as soon as possible and either fix it or make sure everybody knows what the mistake is. Oh yeah, so anyway, so sometimes in my barn and then sometimes in the classroom at Cuesta. So just trying to get you as many lectures as I possibly can. So our first lecture, we're starting in right now with 1.1, right at the beginning, and it's sets of real numbers and the Cartesian coordinate plane. So I started by putting different sets of numbers. Now, depending on what your last math class was, some of this may be review for you. Others of you might be like, oh gosh, I haven't seen that in years. So that's why we're starting at the beginning. So we start with just the basic types of numbers. So the first set of numbers that we always start with are the natural numbers. And they're called the natural numbers because there are natural counting numbers. They are given a double barred or bold N, and they're just our basic counting numbers, 1, 2, 3, 4. And then the dot, dot, dot just means continuing on until infinity. Hold on, a little goose came in here, but away from his family. Okay, the next group of numbers builds on the natural numbers, and it's the whole numbers, which gets this double barred W or bold W. And the only difference between the natural numbers and the whole numbers is that they include the number 0. So 0, 1, 2, 3, 4. Okay, so after that, then what we do is we include the negative numbers, and those are called the integers. And the integers, they actually get a double barred or bold Z, and the reason for that is because the mathematician that named the integers was German, and it's actually Zintiger in German. I don't know why we changed it to integer, but Zintiger, so Z. So in this one, you notice it's got the dot, dot, dot in both directions. But it's basically our regular counting numbers and then 0 and then our negative counting numbers, if you were to say. So going in both directions to negative infinity and positive infinity. But up to there, these are all numbers that are not written as fractions yet. So then we get into what we call the rationals. And the rational numbers are given a double barred Q, and that is to stand, little goose, get out of here. Zoom, goose. Come on, out. Okay, sorry about that, you guys. I told you, it's kind of crazy. The rationals are all numbers that look like fractions, A over B, or quotients, Q for quotient, A over B, where A is an integer, so A can come out of this set of numbers, and B is a natural number, so B, the bottom comes out of this set of numbers. Now this is a different way of writing the set of numbers other than these other three, because when you write fractions, what's the first fraction? I mean, I think our favorite fraction is 1/2, but is that the first fraction? How would we write a list? And the problem is you can't really write a list of fractions. So we use what we call set notation in order to define the rationals. Now, looking in your book does make a mistake on this way of writing it. They try to fix it in wording, but this is the true way that this should be written, not the way the book has it. The reason why this has to be a natural number is because if you're going to put it on the bottom of a fraction, it cannot be 0. So it has to come out of these guys and not these guys or these guys. Okay, so basically it's just every single fraction you can possibly think of. So again, 1/2, negative 1/3. We can even have like 4/2. and that obviously reduces to 2, but 4 over 2 is still a fraction. So it means that even these whole numbers here, they can be written as fractions. So they are in the rationals. So the rationals include, again, all of those fractions or numbers that could be written as fractions. Then we move to the irrationals. And the irrationals actually don't even get a letter, and they don't even use that kind of set notation. It's just the set of all numbers that aren't rational. So these are going to be your non-repeating or ending decimals, and our most common or most well-known irrational number is pi. Okay, so pi 3.14159, going on and on and on, that is a non-repeating decimal. Another one would be a square root that doesn't have a nice answer, so not a perfect square. So like the square root of 2 or the square root of 3, this is also going to be an irrational number. So the weird decimal numbers, or the guys that never end. Now, all of this is building up to the real numbers. The real numbers, which get the double barred R, which we will definitely see a lot, this is the set of all of the rational numbers and irrational numbers. So it takes both of them and combines them together. And basically that means all the numbers that you can have, because any number that can be written as a fraction fits in here, and then all the other guys fit over there. So the real numbers is the collection of all of these sets here. When we talk about the real numbers being the set of all rational and irrational numbers, another way that we could say that is with the union. Maggie, can you come get this goose, please? Yeah. Okay, hopefully the goose is headed in the opposite direction now. Okay, so we use the word union, and union means the inclusion of both sets, so bringing both sets together. So the real numbers are the union of the rational and irrational numbers. So where is my eraser here? So we could, oops, oh, this is not going to go well if things don't erase. So we could say here, Maggie,